Okay, in this video we're going to talk about finding zeros and their multiplicity if it's written in factored form. Okay, so recall that the multiplicity is going to be the exponent of the factor. Okay, and also recall that if x minus c is a factor, then c is a zero. Okay, so on the first problem we have here, we've got this function f of x equals 4 times x minus 5 times x minus 11 times x plus 7 squared times x plus 13 cubed. Okay, so it's asking us to list all the zeros of multiplicity 1, all of them multiplicity 2, and 3. Okay, so the two that have multiplicity 1 are the ones that have factors or exponents of 1. That's those two right there. So if we solved those, okay, that would give us x equals 5 and x equals 11. Okay, so remember, if x minus c is a factor, then c is a 0. So set this equal to 0 each term. That's the reason you get positive 5 and positive 11. Okay. Now, likewise, on the second one, it asks us to find all the zeros of multiplicity 2. That's the one with the exponent 2. We only have the one of them. Okay. So if you set this equal to 0 and solved, you get x is equal to negative 7. Okay. And then all the ones in multiplicity 3 here have the last one. Okay, if you solve that, if you set it equal to 0 and solve it, you would get x is equal to negative 13. Okay, let's take a look at this one. So we have f of x is equal to 2x squared times x plus 5 squared times x minus 7 cubed. Okay, so all the zeros of multiplicity 1, or all the factors that have a 1 as the exponent. Okay, so this one has a 2, right? It's x squared, so the exponent is 2. This one has a 2 exponent, and this one has a 3 exponent. So there's none of them with multiplicity 1. Okay? There are 2 of them that have multiplicity 2. It's the 2 factors that are being squared. Right? And you can think of this x squared as being x minus 0 squared if you want. Okay? It's the same thing, but you still get 0 as an answer on that. Okay? So this x squared gives us x equals 0 as a solution. And then the x plus 5 squared is also multiplicity 2, and that'll give us negative 5 as a solution. Okay, and then the last one would be multiplicity 3. That's this one here. So we get x is equal to 7. Okay, let's take a look at this one. So multiplicity 1. Do we have any that have exponents of 1? Yes, we do. It's right there. So that would be x is equal to negative 9. Multiplicity 2. We have the 1 here. So that's going to be x is equal to 6. Positive 6. And then multiplicity 3, we've got a couple of them. This one here would be x is equal to negative 6. And this one would be x is equal to positive 7. Okay. And now on the last one that we've got here, multiplicity 1. Both of these have multiplicity 1 because they have the exponent of 1. So that's x is equal to 9 and x is equal to negative 13. Multiplicity 2 would be this one here with the square. So that's x is equal to 12. And then multiplicity 3 would be this one right here, which gives you x is equal to negative 7. Okay, let's take a look at a different kind of problem here. Okay, also relating to zeros and multiplicity. Okay, so the first one says, find a polynomial f of x of degree 5 with zeros 2, 6, 0, negative 4, 8. Okay, so if it's degree 5, recall that your degree is all of your factors' exponents added up. Okay, so let's go back up to here and talk about degree for just a second. So if we were looking at the degree of this function, you would say 1, 2, 3, 4, 5, 6, 7. Okay. So this one would have degree 7. You add up their exponents. Or this one would be degree 1, 2, 3, 4, 5, 6, 7. This one would be degree 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then finally this one would be 1, 2, 3, 4, 5, 6, 7. Okay? So the ones that don't have an exponent, they count as 1 degree, and the ones that do have bigger exponents than 1, you add up their exponents, which affects the degree. Okay, so if this one says we have a polynomial with degree 5 with 5 different zeros, 2, 6, 0, -4, and 8. This means that all of these have to have degree 1, right? They can't have other exponents, because if it's degree 5, then, and you have 5 zeros, then all of them have to be degree 1. Okay, so this is going to be f of x equals, we're going to write first x minus 2, that's for this one. Okay, because if I solve this and set it equal to 0, right, it would give me x equals 2. So it's going to be the opposite sign here. Okay, and then the next one would be x minus 6. The next one would be x minus 0. We'll write that in a different way in a second. And then the next one would be x minus a -4, which will turn out to be plus 4. And then the last one would be x minus 8. Okay, so let's clean that up. So that gives us x minus 2, x minus 6. We'll put the x out front. Instead of writing an x minus 0, we'll just stick an x out front. It means the same thing. This one turns into x plus 4. Okay, and this one turns into, well, it's still an x minus 8. Okay, so that's my function. Okay, let's take a look at this one. I ran out of room a little here. That's all right. Find a polynomial f of x of degree 3 with zeros 2, multiplicity 2, and -9. Okay, so this is going to be f of x is equal to x minus 2. That gives me the 2. But I need a multiplicity 2, so I'll put a little exponent on it right here. And then the other one is going to be x minus a -9. Okay, let's clean that up. So x minus 2 squared, x plus 9. So if you solve this one, x plus 9 equals 0, you get -9 as an answer. Okay, let's look at this one down here. So polynomial f of x of degree 5 with zeros 1, -5, -4 multiplicity 2, and 6. Okay, so that'll be f of x is equal to x minus 1, x minus a -5, x minus a -4, multiplicity 2, and then x minus 6. Okay, so that becomes x minus 1, x plus 5, x plus 4 squared, x minus 6. Okay, and now for the last one, polynomial f of x of degree 4 with zeros of 0, 6, and -5. Okay, so f of x is equal to x minus 0, that's the first one, x minus 6 multiplicity 2, that's the second one, and then x minus a -5, and let's clean that up. So this just becomes an x, and then x minus 6 squared, and then x plus 5.